Okay, let's take a look at question 8 in topic set 9, Chem 11. This is a question about molecular orbital and in fact calculating bond strength using the molecular orbital concept. So it's asking us which of the following species would weaken its bond strength when you remove an electron. You need to remember the concept of bond order. Bond order in molecular orbital theory can be calculated by taking the number of bonding electrons or electrons in bonding MO minus the number of antibonding electrons divided by 2. And if you remember, the way we interpret the value of the bond order is that the higher the bond order, the stronger the bond. So the opposite then is the lower the bond order, the weaker the bond. If we look at this equation for bond order, we see that the way we can weaken a bond, which is what the question is asking, is two ways. One is you reduce the number of bonding electron, and that makes sense. If you take away your bonding electron, your bond is going to get weaker. The other thing is you increase the number of antibonding electron. So mathematically, you can think about it this way. If this number drops, your bond's going to get weaker. If this number goes up, your bond is also going to get weaker, okay? Because your bond order value is going to drop. So let's use that to analyze the different species that we're given. We start with H2, and H2 has 2 valence electrons. The molecular orbital of H2 is fairly simple. There's only 2 molecular orbital of sigma 1s and sigma 1s star. Because it's 2 electrons, it's just going to go there. Now the question is, if you remove one of these electrons, what would happen to the bond? Well, it'll get weaker because what you're removing here is a bonding electron. So if you reduce, as we said here, if you reduce the number of bonding electron, your bond gets weaker. So in this case, you will get a weaker bond as a result. You can show this effect by calculating the bond order. The bond order before you take out that electron would be 2 minus 0 over 2, which is 1.0. And then the bond order after you calculate, you take away that electron, is 1 minus 0 over 2, which is a half. So the bond order decreases, the bond gets weaker. Let's take a look at the second species, C2 2 minus. This thing has 10 electrons, and carbon is a second period element, so you have to remember that there's 2 different configurations that we can draw. For carbon, it would look like this. So sigma 2s star, I 2p, sigma 2p, I 2p star, and sigma 2p star. That's the configuration. That's the energy diagram. Now we place the electrons. So 10 electrons means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, taking out 1 electron, what's the effect? Well, the electron is taken out from a bonding orbital. If you take it from the bonding orbital, then the bond gets weaker, as we said earlier. Again, we can do a quick calculation of the bond order before and after the electron is removed. Before, you would get 8 minus 2 over 2, which is a bond order of 3. After you remove it, becomes 7 minus 2 over 2, which is 2.5. Let's take a look at our third species, which is B2. This has 6 valence electron. Boron is in the same group of energy diagram as carbon, so we can use the one that we just drew for carbon. Just repeat that again. Sigma 2s, 2s star, I2p, sigma 2p, I2p star, and sigma 2p star. 6 electrons means 1, 2, 3, 4, 5, 6. Because of Hund's rule, those electrons have to be separated. Taking out 1 electron, again in this case from a bonding orbital, means that we're going to weaken our bond. So same calculation. If I do bond order calculation before, what I get is 4 minus 2 over 2, which is 1. And then after, 3 minus 2 over 2, which is 0.5. So that's a weaker bond afterwards. Let's take a look at the last molecule, which is OF, and tells us to use the O2 energy diagram. So that's what we're going to go with. The O2 energy diagram looks like this. Sigma first, and then pi and sigma. So sigma 2s star, sigma 2p, I 2p, I 2p star, sigma 2p star. The valence electron is 6 plus 7, which is 13 electrons. So let's place the electrons here. That's 6, that's 10, 11, 12, 13. We're going to knock out 1 electron. Now the best electron to take out is the one that's paired up right here, because that's going to be some repulsion going on there. I'm going to take out that electron. Notice in this case, you're taking out the electron from an antibonding orbital. If you take out an electron from an antibonding orbital, you actually make your bond stronger, right? So we can show show this by calculating the bond order before, just going to be 8 minus 5 over 2, or 1.5, and calculating the after, just 8 minus 4 over 2, which is 2. So therefore, this one actually is not going to weaken the bond, it's going to make it stronger. So then the last part here, I just want to summarize the answer, that the ones that are going to get weaker would be H2, C22 minus, and B2. These are the ones that would get weaker if you remove one electron.